Okay, so in this video, we're going to go through Pythagorean Theorem and its application. So this is really a review lesson before we get into the newer pieces of the right triangles part of this unit. And so when we're looking at these, we're going to look at some application problems that involve the Pythagorean Theorem, which means that they're going to involve right triangles. So for each of these, we're going to have to draw a picture and then solve the problem. And so we're reading to determine what's going on. So in Corona, the school is 3 miles west of the post office, and the library is 5 miles north of the school. They want us to tell what is the distance from the post office to the library. So if we're thinking about directions, remember, never eat shredded wheat. So if the school is 3 miles west of the post office, if the post office is here, so label that with a P. So if the post office is there, the school is 3 miles west. West is this direction, so the school would be here, where this is 3 miles. And then the library is 5 miles north of the school, so above the school in terms of this direction. So the library, I wrote it in for library. The library is 5 miles north of the school, then that's going to form a 90-degree angle, right? So going west or east horizontally compared to north or south vertically is going to form that right angle. They want us to find this diagonal line that goes from the library to the post office. So that's the variable we're looking for. So remember that with the Pythagorean theorem, what we're using is the idea that a squared plus b squared equals c squared. And so c is always the hypotenuse of the triangle. And so in this situation, the hypotenuse is x. Remember that the legs don't matter. So a and b, it doesn't matter if I call this a or if I call it b. So I'm going to do 3 squared plus 5 squared equals x squared, because the hypotenuse is always equal to c. It's not changing, hold on. And I'm going to have to solve this equation for x. So if I have 3 squared plus 5 squared, that means that I really have 9 plus 25 is equal to x squared. Since 9 plus 25 is 34, that means that if I take the square root of this, that will give me the value for x. So if x is a square root of 34, and I'm talking about an application, I always want to use this as a decimal. So I'm not going to try to simplify this radical. I'm going to actually take the square root with my calculator. So if I do the square root of 34, that gives me about 5.8. So that means that the post office is 5.8 miles away from the library. So for each of these problems, we're going to draw the diagram, use the Pythagorean theorem to solve for the missing side, and then use a calculator to calculate that value, again, because it's a word problem, so we're going to use decimals. If it were just a straight up, here's a triangle, that's when we would simplify the radical. So for example, a 15.6-inch MacBook has a diagonal of 15.6 inches across the screen. So we're talking about a laptop screen. So that's a rectangular shape. And so that would mean that all of these angles are right angles. It's saying that the diagonal is 15.6 inches. So the diagonal is 15.6 inches. If I think about a triangle, that's going to be the hypotenuse. That's going to be our C value. If the screen measures 7.8 inches in height, so the height of this is 7.8 inches, they want us to find the width. So the width of this would be this value or this value. Really, I can look at either triangle to determine the missing side. So if I think about a squared plus b squared equals c squared, remember that the c is the only one that really matters. So that one has to be 15.6 for c. For a and b, they're interchangeable. I'm just going to put x first. So I'm going to make xa. So x squared plus b is 7.8. Squared is going to be equal to 15.6 squared. So x squared plus, if we square 7.8, that's 60.84. And then if we square 15.6, that's 243.36. So instead of being able to add the two numbers together, I now have a number on each side. So I'm going to subtract the 60.84 because that leaves me with x squared by itself. So that tells us that x squared is equal to 182.52. And so to find x, we have to take the square root. The square root of 182.52 is about 13.5. So that means that the width of the screen is 13.5 inches. Okay, so for the rest of these on the inside, we're going to follow that same process. Draw the picture, use Pythagorean Theorem for the left page. So a 20-foot ramp is used at the loading dock of a facility. If the base of the ramp is placed 8 feet from the base of the dock, how high is the loading dock? So this is saying we have a ramp that's going up to something, right? It's saying the ramp itself is 20 feet. So that's that diagonal piece. That's going to be our hypotenuse. That's our C. The base of the ramp is placed 8 feet from the base of the dock. So we're talking about the bases, that means the bottom. And so that means that that horizontal distance is 8 feet. And they want us to know how high is the loading dock. So that's going to be our variable, is that vertical height. So if we're using the Pythagorean theorem where a squared plus b squared equals c squared, we already know that c must be the 20 because that's the hypotenuse. And then for a and b, again, they don't matter. I'm just going to make xa. So x squared plus b is 8 then. So plus 8 squared is equal to 20 squared. So we square those values, x squared plus 64 then is equal to 400. And subtracting 64, we'll get x squared by itself. So if we subtract 64 from both sides, that leaves us with only x squared on the left. And 400 minus 64 is 336. So square root of that will give us x. So taking the square root of 36 gives us that x is about 18.3. Our units were feet, so our answer is 18.3 feet. Okay, so for example, 4, a roofer leaned a 16-foot ladder against a house. The base of the ladder is 5 feet from the house. So if I have, right, they have a house and they're leaning the ladder up against it, they're doing that, right? And so the house is our right angle. The ladder is 16 feet. The ladder, since it's that diagonal part, is our hypotenuse. So that's the value for C when we plug this into the Pythagorean theorem. It says the base of the ladder is 5 feet from the house. So this horizontal distance is 5 feet, and then they want us to determine how high up the house the ladder reaches. So that means the vertical distance is our variable. If the Pythagorean theorem says that a squared plus b squared equals c squared, where a and b are the legs of a right triangle, then that means that 16 is our hypotenuse. So we're going to place 16 squared by itself for c. Let's just call a x, so x squared plus, we'll make that 5b. Again, I could have done that the opposite order, that doesn't matter. So x squared plus 5 squared equals 16 squared, or x squared plus 25 equals 256. And so for this one, we're going to have to subtract again because we're not solving for the hypotenuse. So if we take and subtract 25 to get the x squared by itself, that's going to give us that x squared is equal to 231. So the square root of 231 will give us the value for x. So x then is about the square root of 231, which is about 15.2. So that means that the ladder reaches 15.2 feet on the house. Okay, so this next piece is talking about Pythagorean triples. So a Pythagorean triple is a set of 3 positive integers. Remember, that means that there are no decimals if I take the square root of these numbers and solve. So 3 positive integers, a, b, and c, that satisfy a squared plus b squared equals c squared. The 4 most commonly known triples are 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. So know that you can use these to find more triples. So what that means is I can take these values, and if I multiply the whole triple by the same number, that will give me a new triple. So that means that if I take all these numbers and I multiply them by 2, that would mean that 6, 8, 10 is also a triple. That 10, 24, 26 is also a triple. That 16, 30, 34 is another triple. And that 14, 48, 50 would create a Pythagorean triple. I can multiply them by any number. So I can multiply them all by 10 or something, and they would be larger numbers, but it will still fit the Pythagorean theorem. So again, I could multiply these by 3. So if I multiply 3, 4, 5 by 3, that would give me 9, 12, 15, and so on. Okay, so I can multiply them by any other integer, and that will create a new triple. So again, like I said with the 10, so if I wanted to multiply them all by 10, that will give me for this one 70, 240, and 250, and that would work in the Pythagorean theorem. So some interesting facts about Pythagorean triples that are not multiples, so the ones that are at the top and the additional triples that exist, because these are not the only ones. Notice that they each have one even number, and that the largest number, the C, is always what kind of number? So the largest is always an odd number. Since they have to have this one even, and the triple and the other one is odd, many triples have 2 odd numbers because of that. So for example 6, we're looking at a right triangle and we're finding x and then identifying whether or not it's a triple. So that means that if x is a whole number, if it does not have a decimal, then these form a triple. If x is a number with a decimal or the square root, then that means that it is not a triple. So if I'm looking at this right triangle, I'm looking for this side, and across from the right angle, that is my hypotenuse. So that means that 40 is C. I'm just going to go left to right. So that means that I'm going to call 24A and I'm going to call X B. So if I'm using this to satisfy A squared plus B squared equals C squared, then I'm going to plug in 24 for A, X for B, and 40 for C. So if I calculate these squares, 24 squared is 576. So 576 plus x squared is going to be equal to 40 squared is 1,600. So to solve for x, I would subtract the 576, so the x squared is by itself. Doing this leaves x squared on the left equal to 1,600 minus 576 is 1024, 1,024. So then taking the square root of both sides to get x by itself, what we're checking is this a perfect square or not? So that gives us the value of 32 for x. And so because this is an integer, then yes, this is a triple. The numbers are 24, 32, and 40. Okay, so that is just a quick review of how we use Pythagorean theorem in application problems, which is page 55 in the notebook. I know I have a lot of your notebooks in my classroom, so you should just kind of be saving this so that you can put it together once we can get those to you. So the assignment that will go along with this is assignment 55A. When you're looking at this in Google Classroom, remember that you're doing the work there and putting your answers, but you're also doing either printing it at home and taking pictures and including those pictures on a new slide, or just doing it on notebook paper and including those pictures on a new slide. So you will not get any points for just color coding or doing whatever the activity is. You need to make sure that you are taking a picture of your work that I can read, that has no glares, that is not blurry, and inserting that into the Google slide deck as a new slide for each of those pages that you do to complete, and then turn it in via Google Classroom.